In this video, I will introduce a technique I call parallel transport. This is a fundamental operation of spherical perspective. It uses vanishing points to make copies of structures and place them wherever we desire on the picture. For instance, in this drawing we see a stack of 3 identical blue boxes aligned vertically. The top box is extremely deformed in perspective. This deformation is required so that in VR all the boxes will seem to have the same size. We control the deformation with precision using parallel transport. In this picture too, I am using the same technique in a simpler way, just making copies of 2 repeating structures, the columns and the spaces between them. In this video, we will deal with the simplest interesting case, which is this. I have a wall going from left to right. On the wall, I have selected a rectangle ABCD. The question is, how can I make a copy of this rectangle, starting at an arbitrary point E placed somewhere further along the wall? I will give you the solution in this video and I will ask you to think about why it works. In the next video, we will reason out the solution in detail and then we will apply it to further cases. So let's go. Here is the solution. Let R be the point on the horizon where the wall vanishes. Pass a vertical through R. Now pass a diagonal line from A through C and extend this line until it hits the vertical at the point V. Now draw the line from E to V. Call G to the point where that line crosses the top of the wall. I claim that G is where the copy of the original rectangle must end. Just pass 2 verticals through G and E to define a rectangle EFGH, which is a perfect copy of the original rectangle. So, that was pretty simple to do, right? But did you understand why it works? Think about it and share your thoughts in the comments. Soon I will provide the answer, so you may want to subscribe. This technique will prove to have endless uses, and we will go over that in future videos. By the way, this video assumes that you know how to draw an equirectangular line through 2 given points. If you don't recall how to do it, then please go back to our first tutorial on the sliding grid method. See you soon with more thoughts on spherical perspective.